Okay, let's dive into this. Welcome to today's Explainer, where we're tackling one of the most urgent, yet honestly most misunderstood challenges facing executive leadership today. For a long time, the boardroom has looked at artificial intelligence as if it's just this single, highly advanced machine, like a brain in a jar. But today, we're going to completely shatter that illusion. In this Explainer, we're focusing on why treating modern AI like a complex corporate organization rather than just one big brain is absolutely crucial to managing your company's risk and preventing what we call catastrophic operational drift.
So here's our roadmap. We'll start by exposing the monolith myth, then look at the rise of the AI fleet and the threat of operational drift. From there, we'll unpack spatial awareness, introduce the Warden framework, and close out with a vital executive principle: broad observation, narrow authority.
All right, Section 1, the monolith myth, or why we really need to stop securing the brain in a jar.
You see, most AI safety thinking still begins with a deceptively simple but incredibly fragile picture. We tend to assume there's just one monolithic model with one objective, something we can easily align, monitor, or if things go completely wrong, just turn off. But there is a stark contrast between that old view and reality. You are no longer governing a single AI model taking clean inputs and giving outputs. What you are actually deploying today is an AI ecosystem. You're governing an entire ecology of intelligence. It's a distributed fleet with persistent memory, external APIs, and specialized agents that can actually develop behaviors no individual component was ever designed to possess.
Let's move to Section 2, the rise of the AI fleet. Think of this as the corporate structure of modern AI.
Modern AI is exactly like a large corporation. It's made up of interacting departments, shared memos, and delegated authorities. Just think about the three distinct tiers here. First, you have foundation models. That's your C-suite, handling the core reasoning. Then you have dozens, maybe hundreds of specialized agents. These are your task forces, out there executing niche autonomous tasks. And finally, you have persistent memory and vector databases. These are your shared archives, storing all the state and context. What's absolutely vital for non-technical leaders to grasp here is that no individual component understands the entire system. The C-suite doesn't know every little thing the task forces are doing and vice versa. Yet, just like a massive global company, the system produces higher-order coherent behavior through the interaction of all these parts.
Okay, Section 3, the threat of operational drift. Let's look at what happens when the fleet actually disagrees.
As this distributed architecture scales up, the risks fundamentally change. A system doesn't need to be consciously evil or go rogue like something out of a sci-fi movie to become incredibly dangerous. The components might just simply stop agreeing with each other. The crucial point here is captured perfectly by Christopher Coleman: local competence does not equal global alignment. An AI agent can be flawlessly competent at its specific local task, like maximizing revenue or optimizing server speed, while simultaneously becoming globally out of sync with the rest of the fleet. And disagreement at machine speed? That quickly turns into massive system instability and fleet-wide operational drift.
To make this concrete, let's look at a specific failure mode called contagion. Now, keep in mind, this isn't malware, this is a pure operational failure. In Step 1, a single, perfectly safe agent trusts corrupted data or makes a locally competent but globally wrong decision. In Step 2, that agent writes its findings into the shared memory, the corporate archive. Then, Step 3, the rest of the fleet adopts this bad context. Suddenly, a perfectly safe reasoning agent is handed corrupted evidence, and it starts reinforcing the bad behavior fleet-wide. Literally, one bad memo just derailed the entire company, and no one explicitly hacked your main model.
Which brings us to Section 4. What is spatial awareness, or seeing the invisible boundaries?
Because an attacker, or honestly just a simple error, only needs to alter one trusted participant or memory source to compromise the whole fleet, AI security completely stops being a single model problem. It becomes what we call a multi-spatial awareness problem. And for non-technical leaders, this is exactly how you prevent that fleet-wide operational drift we just talked about. An autonomous actor occupies many spaces simultaneously. Just look at this list. An agent might appear completely normal in its network space and identity space. Its credentials are valid, it is exactly who it says it is. But its behavior in memory space or temporal space, meaning how it acts over time, might have drifted into a deeply dangerous state. To prevent operational drift, you have to monitor all these invisible spaces at once. This multi-dimensional awareness is literally the only way to catch a locally competent but globally misaligned agent before it infects the rest of the fleet.
Moving on to Section 5, Warden, governing the boundaries.
The solution proposed by the source material is the Warden framework. Warden acts less like a simple prompt filter and much more like a constitutional layer surrounding your machine intelligence. The key concept to understand here is behavioral identity. Because this is a fleet, emergent subsystems can fork and assemble new capabilities without any explicit authorization. They don't have a clean process ID you can just easily flag. Their identity exists only in their pattern of interaction. So, Warden solves this by requiring machine passports. Before an emergent subsystem can act, it must present a passport containing its provenance, its declared purpose, and its behavioral history. If it doesn't align with the Constitution, it is strictly restricted.
As executives, you really have to ask yourselves, how do you govern a system that is everywhere at once? The answer lies in a central Warden principle. Capability does not imply authority. Just because an AI agent knows how to spin up a cloud server or has the technical capability to execute a financial trade definitely does not mean it has the authority to do so. As intelligence scales upward across different spaces and domains, authority should never, ever scale automatically with it.
This takes us to our final section. Section 6, Broad Observation, Narrow Authority, the framework for executive control. To actually maintain control over an AI fleet, organizations have to establish intent-aware infrastructure built on nested governance zones, down at the local, cluster, and domain levels. And your guiding mantra must be broad observation, narrow authority. The observer, Warden, must sit outside the observed system. Why? Because an autonomous intelligence simply cannot be its own final authority. Think about it. If an AI controls its own reasoning, its own permissions, its own security logs, and the very mechanism that decides if it violated a policy, your governance is just a circle. It's useless. Warden independently measures and restricts actions, ensuring that when the system encounters uncertainty or attempts to cross a boundary, the final authority remains strictly, undeniably human.
I want to leave you with this highly provocative thought straight from the source material. The hardest intelligence to govern will be the one nobody explicitly built. Your organization is no longer just deploying code, you are deploying ecosystems where behaviors will emerge that your engineers never explicitly programmed. So as leaders, the time to establish multi-spatial awareness, to start issuing machine passports, and to draw the boundaries of authority is right now, before your fleet scales out of control. Thank you for joining me for this explainer. I really hope this gives you the framework you need to safely govern the AI fleet of the future. So, what's your first move going to be?